Hello and welcome everybody to MyPV's online webinar on the ACTHOR 9S. ACTHOR's big brother has arrived. Maybe some of you are familiar to the ACTHOR AC power controller, and now this single phase version has become a big brother. It has become the ACTHOR 9S. It's now a three-phase version with 9 kilowatts of power. And since a few months the 9S is available on the market, so it's really about time for MyPV to make a first webinar in English on this revolutionary product. My name is Reinhard Hofstetter. I'm responsible for international sales at MyPV, and it's a real pleasure to have you with us today and that you have joined the webinar. I want to start with a short introduction about MyPV. There are the two entrepreneurs. It's Dr. Gerhard Rimpler and Markus Gundendorfer. Gerhard is our managing director, and Markus Gundendorfer is responsible for sales management. Both together have more than a few decades of experience in solar electronics design. And also we have the knowledge of the solar thermal side. So Gerhard was also a managing director of a manufacturing company which produced solar thermal collectors. And myself, I also have the solar thermal side background. I developed flat plate collector systems for many years. And I've seen the limits of the solar thermal technology. I've seen all the technical problems, and I have seen that this technology has not become cheaper over the last years. And now we have PV, and we have the chance to make heat out of the sun's energy many times easier by using wires instead of pipes. And nowadays we also make this cheaper. Some facts and figures about MyPV. We were founded in the year 2011 as a distributor, as a wholesaler actually, and over the years we changed our company and have become a pure manufacturing company. So we terminated all distribution activities for Trina Solar, for Sangro inverters, for example. And in the year 2014 we have had our first product launch, which was the ELWA. And still up to date, the ELWA is one of our flagships at MyPV. The years after 2014, we developed a few AC products, and these AC products were designed to use excessive PV power in on-grid systems. And the result of this revolution was the ACTHOR AC power controller, which was rolled out on the market last year, and this year we have started the rollout of the ACTHOR 9S. A short overview of our portfolio. The whole story began with the DC solution ELWA. It's still up to date the only DC product that we have, and there have been nearly no changes since the invention of the product in 2014. We have a direct DC connection to the heater. So this is the unique thing here. We do not have a PV inverter. We are not on the grid. To make this system work efficiently, this heating element is linear power controlled, and this is the basic know-how of MyPV. We have implemented a power control unit, a power stage, and it controls the ELWA from 0 to 2000 watts according to the available PV power. There is also an MPP tracker integrated, which is usually in an inverter, but we do not have an inverter here in this concept. There is also a mains plug for backup, but this is an option. It's not necessary to use it. In Middle Europe, we recommend to use this option during summertime. We have plenty of solar yield available to do the hot water heating, and in case that there is 1 or 2 days with bad weather, you can use power from the grid. It's not necessary to start your conventional heating system for just a few kilowatt hours of backup energy. And during the winter time, we recommend in Europe not to use this AC backup. because your conventional heating system does the backup anyway. So your biomass boiler, your heat pump, your gas boiler, district heating, whatever. And therefore the energy from the grid is maybe too expensive during wintertime. So it's just an option. It's not necessary to use it. It runs on DC alone, and it also works when there is a blackout. While the DC solution has a linear power control unit from 0 to 2000 watts, all our AC solutions have a linear power control capability from 0 to 3000 watts. And we have invented the AC ELWA-E, and the idea is to use excessive PV power which usually would be sent to the grid. And therefore we do not have a DC connection here. All the power is always drawn from the socket, but it only takes the amount of power out of this socket which would be sent to the grid. So a power stage from 0 to 3000 watts is essential to make an immersion heater, to make a resistor PV ready. Because PV power changes all the time. When you just switch on the light in your building, you have less PV excess available, and the heater will immediately reduce its power output to ensure that there is no feed-in and no import from the grid. It makes the balance in the feed-in point very fast and very accurate, especially when the excessive power information comes from the MyPV power meter. So this small unit is installed in the feed-in point, and it measures the excessive power on all three phases. It also works in single-phase systems. And usually the power meter and the AC ELWA-E communicate via an Ethernet network. It's also possible to connect them directly, no problem. And here we have a combined solution. The immersion heater and the power stage from MyPV is implemented in one solution. So this is very cost-effective. In some cases this is also a disadvantage, because there can be an immersion heater on the site which should be used also in the future. And what is the solution here? We use the THOR power controller. So we have separated the power stage from the immersion heater, and the THOR can be used to use an average, a standard immersion heater, and makes this heater PV ready. There is also an accessory part from MyPV available which exactly fits to the THOR, but honestly it can work with every single phase heater between a nominal power output from 500 to 3000 watts or 3500 watts. This power range is okay, and the THOR can control this power output linear. Also, the power meter can be used to send the excessive power info to the THOR, and one of our greatest decisions, one of our greatest strategy decisions at MyPV was to make our communication interface open for third-party control. And this means that also other manufacturers can control our systems. Then we do not need the power meter. We can get the excessive power information from a compatible inverter manufacturer, from a smart home manufacturer, from a battery manufacturer. So you do not need the MyPV power meter additionally. And yeah, this was it was a longer overview. So the ELWA, which was the first product, is directly connected to the panels. There is no possibility to use the PV power for electronic devices. It's all used for heating, but we have the big advantage here of cables instead of pipes, and this makes the system so many times easier compared to a solar thermal system. And nowadays it's also cheaper than conventional solar thermal systems. Some facts on this slide. You will get the slide of today's presentation after the webinar, no question, and you can take a closer look on all the basic information here. The target temperature is adjusted with the rotation knob, and the connection thread, which is now behind the cover here, is a 1.5-inch connection, which is a standard connection thread on most of the tank and boiler manufacturers. The optional backup power is 750 watts AC. One thing is special on the ELWA. You can use two units parallel connected to one and the same module string. This leads to the advantage that on bigger tanks the target temperature of the unit on the top is reached very fast due to the smaller volume, and the rest of the remaining energy can be used by the unit on the bottom. Practically, this setup here is often used that the priority unit, the master unit, is in a hot water boiler and the slave unit is in a storage tank. No problem, this does absolutely not matter. The AC ELWA-E is not directly connected. It's an AC product, as the name says. There is the PV inverter and we only use the excessive energy which would be sent to the grid. It also has a 1.5 inch connection. The dimensions here are absolutely the same as the dimensions of the ELWA. And the devices are really quite smaller than most of the people would expect. The dimensions here are approximately 13 times 15 centimeters. So this chassis here, this body here is really small. And the length of the heating elements inside the boiler is 47 centimeters. The technical data on this slide, AC power controller from 0 to 3000 watts. And what is very, very important to say, all our AC power controllers have a pure sinusoidal current consumption. We do not use thyristors or phase angle control. We have always a pure sinusoidal wave to control our power output. And this is an essential feature, especially in Austria, in Germany, in Switzerland, where we are compliant with the rules of the grid operator in doing so. So we are not allowed to use a thyristor in Austria above a power output of 200 watts. Nevertheless, some installers install it anyway, but actually they are not allowed to do so, and there are still plants going offline now because they are not grid compliant. With MyPV solutions you can rely on the quality, and you have a solution that is a real sinusoidal power control unit. Okay, and now to the actual power controllers, and this leads to a few other applications. Not only hot water heating, also electric space heating can now become PV ready due to our linear power control unit. And I want to start with the question, why does hot water heating and space heating become PV powered? Why is that? And the answer is the base for all our inventions, also for the ELWA. PV panels have become so cheap, we can now also use this power for heating. So this was unthinkable a few years ago. When I heard about the idea to use PV power for heating, let's say 7 years or 8 years ago, I was scared. I could not imagine to do this because PV power was so expensive. But the things have changed. It's now one of the cheapest forms of energy that we have on the planet. And of course we can use it for heating. Why not? Because it's electricity? That's not the problem. We have a lot of advantages when we use wires instead of pipes. But some people, especially here in Austria, they are skeptic to use PV power. They want to rely on solar thermal systems. They want to continue to work with solar thermal systems. But I know all the disadvantages there. You have wires, you have pipes, you have pumps, you have valves, you have expansion vessels, you have to insulate the circuit, you have a maintenance, you have to maintain the anti-freezing liquid. So still a lot of copper and aluminium is installed in these products, and it's nowadays so many times easier and also cheaper thanks to this great development here. What most of the people know is how much energy they use in their building for their electric appliances, so for light and devices and electronics like TV and whatever. So for a single family home in Austria, for example, we need 4,000 kilowatt hours of energy per year for our electric appliances. What hardly anyone knows is that for a 4-person household we also need 4,000 kilowatt hours of energy for hot water heating. And this is what we can already do in all the buildings that we have, in old buildings, in new buildings, absolutely no problem. This can be a cheap alternative to battery systems, but it can also be a cheap expansion of existing storage capacities of batteries. And what we can do for new buildings, and for buildings that are refurbished is we can also think about using PV power for electric space heating, because for modern and new buildings the demand for space heating energy is also approximately as low as the energy for electric appliances and for hot water heating. It would be nonsense to use the technology in an old building with a huge demand of space heating energy. Let's be clear here. We do not recommend to use our technology here, but we can always use it there and also here for new and refurbished buildings. When we take a look on the storage capacities in a single family home, in every case the battery comes to our mind, and an average storage capacity in a single family home is a 5 kilowatt hour, let's say a 10 kilowatt hour battery. When we use the remaining excessive PV power for hot water heating, we have additional 15 kilowatt hours capacity available when we look at on a hot water boiler with a 300 liter volume. And when we also consider to use electric PV power for space heating, we can use the concrete floor in a building as a thermal storage. And for a 100 square meter building, the storage capacity, the thermal capacity of this floor is approximately 25 kilowatt hours. And when we want to make the transition to renewable energies in Europe and worldwide, we have to use all the existing storage capacities that we have available. And that's not only the battery. When we think about using excessive PV power for hot water heating, it's all about your PV self-consumption ratio. I use this slide here. It's from the Technical University in Berlin. I'm sorry this diagram here is in German, but I try to explain it to you. And this diagram shows the self-consumption ratio in a single family home depending on the size of the PV system. So for a 5 kilowatt peak on-grid system, we have an average self-consumption ratio of 1/3. The rest of the energy is sent back to the grid because there is a production when you do not need it, and you need it when you do not have production in the evening, and that's why we only can use approximately 1/3 of the energy. This solution here strongly depends on your location and on the revenue that you get for the feed-in of the energy. In Austria, you'll nearly get nothing. So 3.9 cents per kilowatt hour. That's nothing. That's less than the price for heat out of wooden pellets or whatever. And so it's about to increase your self-consumption ratio. And the question is how you do it. The most popular form is you add a battery. Yes, you can do so. You increase your self-consumption ratio to 2/3, for example. But this is a huge step on the investment costs. As an alternative to the battery, you can use a MyPV system, and you increase your self-consumption ratio even higher due to hot water heating at much lower investment costs. So we can be an alternative here, but we do not compete with batteries. Batteries are the future, definitely. I think in 10 years from now we will have a battery storage system in every house with a PV system. I hope so. And that's why we do not compete with the battery. It is always possible to use both systems together. And as soon as the battery management system is compatible to MyPV, we can combine the solution. We raise the self-consumption ratio to a maximum here. And the sequence that we recommend is clear. If there is a battery, the battery should have priority. So only start hot water heating when the battery is fully loaded, because as soon as it is heat in the hot water boiler, we cannot get electricity back out of it. That is clear. So priority should be on the battery. That's our recommendation. Absolutely clear. But on average storage capacities, we have this situation, and sometime in the late morning, let's say on a sunny day in spring or autumn, that the battery is fully loaded. And from this point forward, we have a lot of remaining PV power available for hot water heating. You also can calculate this. We have a sales tool. It's a paper disc, and here you can use this arrow to set your PV power, and on the tables on the left, on the right, you can read the expected results for PV self-consumption ratio and hot water coverage ratio. This is a tool that most of our clients use for their sales activities. It's very good for a rough estimation, to tell the people what they can expect and to give the customer an idea of his performance that he can expect. So I can strongly recommend this, and you can have as much of them as you need. We will send it to you for free. Okay, this was a long introduction. 20 minutes are gone, and now we come to the basic content of our today's webinar, the Actor, and especially the Actor 9S, the big brother of the Actor. Here we have the power meter. As I already told you, it's installed in the feed-in point. There are clamp-on transducers available with the device, which are always in the box, and the power meter can be used to give the Actor the excessive power information. You can connect them usually via a router, so via Ethernet. The connection between the units is made, and if there is a compatible system available, you can also use the signal source from the system. For example, SMA, Fronio Smart Meter, E3DC, Vata battery storage system. We also work with Victron, SolarLog, a lot of famous names here, and of course there's the huge group of smart home systems, because smart home manufacturers always look for new appliances, and of course now also PV and hot water heating gets into their focus, and that's why they are now, or many of them are already compatible to MyPV. If you miss one of your favorite systems here, I will give you the communication description of our system. So this is not a secret. I really give you the PDF file with all the communication registers of our Modbus TCP protocol, and you can implement your own control system. We are absolutely open for anyone who wants to control our unit. And this is it. This is the THOR Photovoltaic-Power-Manager. Actually, technically speaking, it's an AC power stage. At the beginning of the product, people thought this is a smart home system. The screen on the box here reminded them of a smart home system, but technically speaking, it's an AC power stage. And you can use this power stage to make a stupid on-off resistor PV ready in terms of linear power control. So you connect your immersion heater to this socket here, and the Actor is able to set the power on the resistor which is available in this second. I compare it with a gearbox. Let's compare it with a car. You have a motor which gives you the power, and you have the wheels on the road. There has to be something in between which ensures that the RPM, the rotations, are correct. And it's exactly the same when you make hot water from a PV system. You have the motor on the roof, it's your PV array, and the power changes all the time. There are clouds moving, and also loads of in the building electric appliances are switched on and switched off, and the amount of excess power which is available in this second changes all the time, and the Actor and the AC ELWA-E solutions, they react on this very fast and very accurate, and they ensure the balance in the feed-in point. And the Actor makes the immersion heater, which was stupid before, let's say it this way, now PV ready. All the technical details are on this slide. Again, it's a 3 kilowatt power stage. You can also use the Actor in 60 Hertz power grids, and the dimensions are really small. So this is smaller than a small sheet of paper. This is just one of our many unique sales points here. So we have a very compact device. All connections here are pluggable. So not only the load, also the Ethernet connection, but this is clear, but also the temperature sensor plug, the relay plug for the additional power output is pluggable. We have a very color touch display, which gives you a very intuitive control capability. And we have an open interface. So if you want to control it yourself, let's say with your Raspberry Pi or whatever, you can control it on your own. We give you the communication protocol. So a lot of unique sales points that you do not find on competitor products. And this is something that we are really proud of. I have to say it directly. I'm sorry. And now we come to the ACTHOR 9S. It is in the same case. It's not bigger than the single phase product, but instead of the mains socket on the bottom, we have now 3 plugs for all 3 phases. And this is now a 3-phase solution for a power output from 0 to 9,000 watts. We have all the details again here on the slide, and with this benefit of the 3 power outputs, we can use many more. We can think about many more applications here. So using a 3-phase resistor for a power control of from 0 to 9,000 watt is just the general idea. Everyone thinks about this. But what is special on the ACTHOR 9S, and this is also something that you do not find on competitor products, we can change the control phase from each output. So you can have a linear power controlled output on phase 1 or on phase 2 or on phase 3. This is the cool thing here that no one else has. And this makes it possible to control 3 single phase 3 kilowatt resistors also linearly, one after the other. So let's say you have 1 kilowatt excessive power available. You will use this power linear controlled on the heater on the top. Let's say you have 4 kilowatt excess available. Then we switch the load static for the heater on the top, and we do the linear power control at the heater in the middle. And for 7 kilowatt excessive power, we switch the heater on the top and in the middle static, 3 kilowatt each, and do the linear power control here on the heater on the bottom. And we do this as long as our temperature sensor tells us to stop, or as the thermostat in the heater disconnects the load of the immersion heater. So both is possible. And due to the fact that we can control each power output linearly, we can also think about pure solar electric building installations. So also the space heating can be done PV ready now. So hot water heating with 3 kilowatts, for example, and 2 heat zones for electric space heating with 3 kilowatt each, for example. This is possible, and for a modern building with a very low demand of space heating energy, we can replace the whole conventional heating system. So we do not have pipes in this building, only for the cold water supply and the water supply to the bathroom, but not for space heating anymore. The ACTHOR can also be combined with a heat pump. Both ACTHORs can do this, which means that with this relay output here, we can release a heat pump from a certain level of excessive energy. So as soon as there is enough energy available to drive the heat pump, to start the heat pump, we can release it, we can start it with our potential free contact, and then you have the additional performance factor of the heat pump, which can be used for heat production. One detail that is very important, we are talking about 3-phase loads for the ACTHOR 9S. What we always need is the neutral conductor. Especially in Switzerland, we often have found the situation that there is no neutral conductor on existing immersion heaters. There are 3 times 400 volts immersion heaters, and we cannot use them without the neutral conductor. So technically speaking, we need a 3 times 230 volt heater with a neutral conductor to be used by the ACTHOR. And this is the ACTHOR display. So on the left side we have the version for the single phase ACTHOR, for the 3 kilowatt ACTHOR, and on the right side we see the ACTHOR 9S. And for those of you who are already familiar with the ACTHOR and who already have experience with the actor, all of you will find a familiar design. If you already are used to work with the actor, you should not have any problem to use the actor 9S. It's nearly the same design. The bar chart, which shows the linear power output, is just split in 3 parts, and of course you see the power output on all 3 outputs separately here. With the actor products, we have a lot of possible applications. The actors come with 8 operation modes, and I would say with these 8 modes we can cover 95% of all the applications out there. And for the remaining 5% of the applications, we offer our communication protocol. If you or your client needs a very special design or very special behavior of the actor, you can program it yourself. We give you the description of our interface, and you can close the gap if you do not find the right operation mode in our standard list. So all of the operation modes of the actor are also implemented in the actor 9S, with one exception. There is no need to have a 6 kilowatt operation mode in a 3-phase 9 kilowatt product. So that's why mode 3 is not available on the actor 9S, but all the others. And now I want to give you a very rough overview of these modes. I do not want to go too far into the detail. You should just get a short impression here. So hot water heating with 9 kilowatts. So a 3-phase heater can become PV ready with the actor. Excess power info, as always, can come from the power meter or from a compatible manufacturer. An accessory part which is available for the single-phase version and for the 3-phase version is our MyPV Immersion heater. So the heater itself is a standard heater, it's just on and off. But with the actor or the actor 9S, you have a complete set. If you prefer to have it all from the same supplier, you also get this accessory part from MyPV directly. The single phase 3 kilowatt version comes with a 2.8 meter power cord, and the 9 kilowatt 3-phase heater does not have a cord. You just need to use a 5-pole standard cable to connect the heater to the actor 9S. And for the actor 9S, we have the already explained way to use 3 single-phase heaters here and control one after the other, or in combination with the 3-phase actor. Please do not confuse with the mode 2 here. Mode 2 is stratification charge, and with mode 2 we change the load from one 9 kilowatt load to the other. So this is a very simplified diagram here. To do this with the actor 9S, you also need 2 relays, one which is normally closed and one which is normally open, to change the active load which is supplied by the actor 9S, and in doing so one after the other can be used linearly. Again, as you already have heard it from the ELWA, it is possible to use one heater in a hot water boiler, for example, and the other one in a storage tank, or in 2 different storage tanks. This does not matter how it is integrated in your hydraulic. And all of our products, by the way, they can always be used in space heating water, so in storage tanks. For your conventional systems that are already out there, you can also support your hydraulic space heating system by using our immersion heaters and our solutions. It does not have to be a hot water boiler in every case, just to be clear here. This is the screen for mode 4 when we combine the solution with a heat pump. Both the heat pump and the resistor which is supplied by the actor should send the heat to the same boiler. This is important, and as soon as we have a certain level of excessive power available, and this level can be defined individually, the actor will release the heat pump via its integrated relay contact. And then both systems work together. So the fluctuating, changing PV power is controlled by the heater via the actor, and the heat pump works with its coefficient of performance additionally. Another operation mode is mode 5, electric space heating and hot water heating. So in this concept we replace all the hydraulic space heating system, and again we are talking about a very energy effective building here. It's a new building or it's a refurbished building. It's not an old building where we can do so. And in this operation mode we can supply 2 electric space heating zones and 1 hot water heater linearly with PV power. Of course you can adjust a minimum temperature, a backup temperature, which is always ensured also with power from the grid if necessary, and you can also define a time frame for the space heating zones where you want to reduce the temperature a little bit, for example over the night. And you can adjust weekdays where you have to ensure a minimum temperature in the hot water boiler. Again, for our hot water backup you can define 2 time frames where the minimum temperature has to be ensured, for example 2 hours in the morning when you go to the bathroom, or 3 hours in the evening, and in between the system will only use excessive PV power. The reason why this system is more ecological than a heat pump is that we can use the PV power also for electric appliances. A heat pump is not able to do so. It can only produce heat. The power for your appliances has to be imported from the grid in every case. And now you can say, okay, but I can combine a heat pump with a PV system. Yes, you can do, but then you have 2 expensive systems in your building, and a heat pump is not very fits not very good for PV systems, because you cannot control the power input for the compressor and the heat pump linearly. This is a static power input. While we can adjust the power of an immersion heater, of a resistor, every second new on a new stage. So this is PV ready. And in many projects where the sum over the year of the power grid import is smaller than in the compared system with the heat pump, we are talking about the more ecological solution here. So while the heat pump uses power from the environment by evaporating a cooling liquid in this evaporator here, we use the energy from the environment from the same source. It's the sun in every case, but we use it directly. And we do not use a cooling liquid to transport the energy. We use wires and we transport electric energy. And this means easier installation, this means less maintenance, and this means also silent systems. So we do not have any noise as with the heat pump. And of course we have already done such projects. This is an example of a project not far away from my location. It's in Austria, and this is a single family home. And you might ask, how big has the PV system needs the PV system to be? And the answer is always make the roof full up until the last corner. So do not take the money and install a conventional hydraulic expensive heating system in your basement or in your boiler room. Use this budget and install the energy source on the roof. This is our philosophy here, and use all the space on your roof. So when we think about using PV power not only for hot water heating but also for space heating, we are talking about a few things that we have to ensure. First, this has to be a very efficient building. It's not an old building, it's a new building. And for European conditions, we're talking about a maximum heating demand of approximately 50 kilowatt hours per square meter and year. So this has to be a low energy building. And when we're also talking about supplying the space heating, we are talking about the inclination of the roof. So in Austria we have a lot of snow in the winter. When I look out from the window, we already have let's say 20 centimeters in front of our building here, and we have to ensure that these panels are not covered by snow. The inclination here is 45 degrees, and this is enough to ensure that also during winter time this PV system is free of snow. And for hot water heating alone, this is not the real problem. You can also have a flat roof with very low inclination of your panels. In Greece, for example, we often install systems horizontally because the architects do not want to see the panels. And when we're talking about hot water heating during summertime, this is absolutely okay to do so. But for space heating during wintertime, you have to consider the inclination as well. A few other projects are in the pipeline. This is a smaller building, just 5 kilowatt peak on the roof, but nevertheless for this small building we have less of energy demand from the power grid. We need less energy for heat backup of hot water and space heating and for the supplyment of the electric loads, and this makes the system more ecological than the comparison with the heat pump. And additionally, you have the excessive PV power that cannot be used for heating anymore, for example during summertime, available for other people in the power grid. So you have renewable energy also that can be used by others, and this is not the way with the heat pump here. Some other modes. Mode 6 is electric space heating alone. Mode 7 can also give you a signal output, a PWM output signal, or the PWM output signal to control the RPM of a hydraulic pump, for example. So these are special modes here. And what I want to show you as the last mode is one of my favorites, especially when we are talking about international projects. It's mode 8. This is the frequency mode, and this means that the actor or the actor 9S, they do not get the excessive power information via the Ethernet socket. They are controlled by the frequency in the AC grid. So this can only happen in off-grid systems, of course, where it's allowed to change the frequency. And for this projects which are really in remote areas, we have the possibility to be controlled, let's say by SMA Sunny Island, Steyr Extender or Victron Multiplus, and to expand the existing battery capacity. Once the battery is fully loaded, we use the rest of the remaining PV power for heating. And in off-grid system, this means we use energy that is usually not used by anything. When you're off the grid, you cannot feed in. When you do not have a load right now, you do not need it. And when the battery is fully loaded, you cannot charge the battery. So the PV system usually needs to be shut down. But now we can use the remaining energy for heating. And some of the Austrian stereotypes here, we have our mountain shelters, a lot of them here in the Alps, and when we are off the grid we can now do also the hot water heating as soon as the battery system is fully charged. But beside these Austrian examples, we have also examples on the other side of our tiny little home, which means a project in Australia, where we do the hot water heating in a remote avocado farm. So the PV power is used to heat the water in the production process where the fruits are washed. So very interesting applications in Australia. And many other interesting projects are in the pipeline. I hope I can tell you about them soon. So much more interesting off-grid projects in the pipeline. Okay, wow, we are quite good in time. Let's take a look on the actor and the actor 9S advantages. So easy installation. All our connections are pluggable. It's very user-friendly with the color touch screen, which is not available by any other competitor product. We have a flexible control. You get the protocol, the description of the communication protocol if you like, and already there are a number of inverter manufacturers, battery manufacturers, and smart home manufacturers who have implemented our communication. The Actor and the Actor 9S are very compact, so this is an amazing power density compared to bigger solutions where you have to open a cover, you have to assemble terminal blocks, you have to assemble PG connections. This is all obsolete with the Actor. What is most important, and I already mentioned this when I presented the AC ELWA-E, we have no thyristors in our controller. We have a pure sinusoidal current output, and this is really a very important quality sign from MyPV. The concept hot water from PV or space heating from PV leads to maintenance-free systems. We have cables instead of pipes, and we do not need to maintain a cooling liquid. We do not have to maintain a hydraulic system or whatever. This means for electric buildings also a downsizing of the building installation room. The conventional boiler room is now gone. Everything that is left from the conventional system is the hot water boiler, and we need the hot water boiler as a thermal storage volume. So it does not work with, what is the English word, with instantaneous electric heaters, with huge power output and without water volume. So this is not PV ready. When you have an instantaneous electric water heater and you take a shower in the evening, you need 20 kilowatt power. And of course this comes from the grid then. Otherwise, where should it come from? If you use it from the battery, this is not very wise because the lifespan of the battery also belongs to charging circles, and of course when you use this amount of energy in the evening for taking a shower, this will dramatically reduce your lifespan of the battery. So we always need a hot water boiler as a storage volume, as a storage volume for the excess power of the day, and in doing so we can use it in the evening when we take the shower, for example. What about the costs? The cost for the Actor and the Actor 9S are 624, respective 749 euros for the end customer, exclusive value-added tax. This is just a recommendation from MyPV. We as a manufacturer, we do not make direct business to the end customer. This belongs to our sales partners, the installers, the wholesalers, the distributors, and this is just a recommendation from our side here. Where do you find information material? No question, you find it on the website. A lot of the material for marketing, a lot of the manuals, wiring diagrams, whatever, are available in German and English. And now also manuals and data sheets for Actor and Power Meter are available in French, are available in Spanish now. Just check our website, choose the language that you need, and you will get the info that you need. Otherwise, contact me directly. You will get my contact data with the email that I send you after the webinar to provide you the webinar slides of today, and then you have my direct contact data as well. Okay, where to buy? A lot of distributors are already available. We have our best developed distribution network in the German-speaking countries, Austria, Germany, and Switzerland, but also in a few other countries we are already available with a few wholesalers, and the list of course continues to grow. Just check the website, and if you do not find a distributor, a wholesaler in your country, we can supply you directly as long as you run a business. I cannot provide products to you if you are an end customer. I have to apologize, but also for installers we send the products around the globe already. Okay, I have to say thank you. We are very good in time today. It is really a new technology. It's a new way to use PV power, but it will be the future. I'm absolutely sure about that. I know the thermal side like my pocket, and I can tell you PV is continuing to become cheaper and cheaper, and the buildings are becoming better and better in thermal terms, and of course hot water heating and also space heating will become PV powered in the future. I'm sure about that. And maybe it's a little early also here in Austria to talk about electric space heating. We have our lead projects out there, of course we have them, where we also do the space heating side. But to start with our solution, it's the easiest way to think about hot water heating. So let me tell you this at the end. The AC.THOR are not for electric space heating alone. Of course you can use it for hot water heating, and this is the normal way to start with our solutions. The easiest product from MyPV is the DC solution ELWA. So there is nothing easier. You just have two wires from the PV panels, DC plus and DC minus, and you connect them on the bottom of the heater. There are multi-contact plugs on the bottom of the unit. And for all the years where I was researching in the solar thermal industry, we always looked for a plug-and-play solar thermal system. And now the ELWA is this plug-and-play system. It's not a thermal system, it's an electric system, but the installation is so easy that my 5-year-old daughter can install this PV power supply. It's just a matter of connection of multi-contact plugs, and you assemble it by turning the connection thread into a boiler, and that's it, and then the installation is ready. I always recommend the ELWA as a easiest way to start in a new market. Of course, the webinar today was about the AC.THOR, where we are always on the grid, where there is always an inverter, but there is nothing easier to start with than the ELWA. And inside of the ELWA there is also a data logger, by the way. With an infrared interface you can use the connection of the infrared to download all the data, and you can check the performance, and you see the solar yield, you see the temperature increase. Of course you can also adjust settings, for example the AC backup. You can change the starting time, you can change the AC backup temperature, which is a real cool feature. So with the rotation knob here you adjust the target temperature for PV power, but independent from this you can adjust a backup temperature with the optional AC backup, which is lower, and in doing so we avoid import from the public power grid as much as possible, and we still have a remaining storage capacity for PV power available. For example, I heat up the hot water boiler with AC backup to a minimum temperature of 40 degrees centigrade, and I set the target temperature with the rotation up to 60 degrees centigrade. I have 20 Kelvin of storage capacity still available for PV power, and I avoid the energy import from the grid as much as possible. So a short excursion on the ELWA. It was a real pleasure. So thank you very much to all of you who have participated the webinar, and to all of you I want to say thank you again, and have a nice evening, have a nice afternoon, or wherever you are located, have a nice day. Thank you very much, and all the best from my side, from Austria. Goodbye.